2013 ADMAC paper. And as you can see, you have 2 hours and 40 minutes to do the ADMAC paper. It's 4 sections. You do everything from section 1 to 3. And then section when you get to section 4, you choose one question. Section 4 is statistics, which is the best topic in mathematics, as well as kinematics, which is motion in a straight line. So, you go ahead and you do what you want to do. So let's get started on this paper. Question 1. Question 1 says, f of x is x cubed minus x squared minus 14x plus 24. And it says, use factor theorem to show that x plus 4 is a factor of f of x. Now, this is quite simple. Now, if x plus 4 is a factor, then we know that if x plus 4 is a factor, then we know that f of negative 4 is equal to 0. That's what we do know. If x plus 4 is a factor, then f of negative 4 is equal to 0. So that's what we're going to show. All right, so this is what we're going to show now. And so f of negative 4 is going to be equal to, so we're going to put negative 4 into the function. So it's going to be negative 4 cubed minus negative 4 squared minus 14 times negative 4 plus 24. And this should be equal to 0. So when we check it out, what we're going to see is negative 4 cubed, that's negative 64. And then we have negative 4 squared. Negative 4 squared is 16. So this becomes minus 16. And then we have minus 14 times minus 4, that becomes positive, I believe that is 56 plus 24. Is indeed 0 because negative 16 minus negative 64 minus 16, that's negative 80. And then this part that says 56 plus 24, this is positive 80. And negative 80 plus positive 80 is 0. Since this is 0, we can conclude hence. So we can just make our conclusion, hence x plus 4 is a factor of f of x. Now that we've gotten that out of the way, let's look at part 2. Part 2 goes further and it asks us now, it says, determine the other linear factors of f of x. So to determine the other linear factors of f of x, all right, we can do it using synthetic or polynomial long division. I prefer polynomial long division, but many persons do synthetic division, so it's up to you. So using polynomial division, you have x plus 4, and you're going to divide f of x and f of x, which is x cubed minus x squared, x cubed minus x squared minus 14x plus 24. So when we do this division, we're going to say x into x cubed, and x into x cubed goes x squared. X squared times x is x cubed. And then x squared times 4, that's plus 4x squared. And then we do our subtraction. When we do our subtraction, we're going to get x cubed minus x cubed, that cancel. Minus x squared minus 4x squared, that's going to be minus 5x squared. And then x into minus 5x squared, that is absolutely minus 5x. Then we say minus 5x times x. Minus 5x times x is minus 5x squared. And then minus 5x times 4, that's minus 5 times 4, I believe that's 20. That's minus 20x. But don't forget we have to bring down our minus 14x here. So when we bring down our minus 14x here, now we can go ahead and do the subtraction. When we do our subtraction, all right, what's going to happen is minus 5x squared minus minus 5x squared, those cancel. Minus 14x minus minus 20x, that just becomes 6x. And then we bring down our 24. Then we're going to say x into 6x. X into 6x is positive 6. And then x times 6 is 6x. And then 6 times 4 is 24. So we're nice. All right? We're nice. When we do the subtraction, that's going to leave 0. Good. So pretty much we can rewrite now f of x as, rewriting f of x as the product of, can be rewritten now as x plus 4 times x squared minus 5x plus 6. So f of x can be written as x plus 4 times x squared minus 5x plus 6. But then x squared minus 5x plus 6, that can be factorized. We can always factorize this part now. X squared minus 5x plus 6, we can always factorize this part. When we factorize this, what we're going to get is x plus 4 times, now x squared minus 5x plus 6, that's going to be x minus 2 times x minus 3. All right, so the other two linear factors are x minus 2 and x minus 3. Anytime you finish a question, I really like when we put it in words, so we can say hence. It's always good to put what we want to say in words. Hence, the other linear factors, are x minus 2 and x minus 3. Nice and easy. And that takes care of that. Those are the two other linear factors. This takes care of the first part of the question. Part 2. Part 2 says a function f of x is given as 2x minus 1 over x plus 2. So it tells us this is part B, and it says that f of x is equal to 2x minus 1 over x plus 2. All right, f of x is 2x minus 1 over x plus 2. And let's hear what they're asking us. The next part of the question is saying find an expression for the inverse function. All right, so to find the inverse, first thing we're going to do is call f of xy. And so that implies we interchange x and y to say x is equal to 2y minus 1 over y plus 2. That is generally what we do. And then we're supposed to make back y the subject. When we do this now, what we're going to get is cross multiply to get xy plus 2x, xy plus 2x is equal to 2y minus 1. xy plus 2x is equal to 2y minus 1. Nice, nothing wrong with that. Then what are we going to do next? Next thing that we're going to do is to make y the subject, we need y to be on the same side. So we're going to bring y over here. So bring over the minus 1 over here to get 2x plus 1 So 2x plus 1 is equal to, bring xy over here to get 2y minus xy. And then what are we going to do next? We're going to factor out y. So factoring out y, we get 2 minus x. Nice and easy. All right, so what are we getting? We're getting that 2x plus 1 is equal to y times 2 minus x. So what that means is if we make y the subject, clearly y, which is f inverse, so f inverse is going to be equal to, we divide both sides by 2 minus x to get that f inverse is actually 2x plus 1 over 2 minus x. That is f inverse. If you're wondering how did I get that, remember f inverse is y. If you just divide both sides right here by 2 minus x, that will give you f inverse. So that's all I did, divided both sides by 2 minus x. And then the 2 minus x right here cancels the 2 minus x right here. So f inverse is 2x plus 1 over 2 minus x. All right, now the next part of the question says, the function g of x is equal to x plus 1. So they give us another function g of x. Let's put that function in a different color. They give us some function g of x. And they tell us that g of x is equal to, what is g of x? X plus 1. So g of x is x plus 1. And then they're asking us to find out what is fg of x. Fg of x means that we put g of x into f. Fg of x means we put g of x into f. That's what fg of x means. So anywhere we have g of x, anywhere we have x, we put g of x there. So it's going to be 2 times g of x where x is, and g of x is x plus 1. So it's 2 times x plus 1 minus 1 over, put x plus 1 right here for x, over x plus 1 plus 2. And this is fg of x. And of course, we're supposed to simplify it. So let's simplify it. This is really now 2x. This is really going to be 2x plus 2, and 2 minus 1 is plus 1. So it works out to be 2x plus 1 over x plus 3. So this is fg of x, 2x plus 1 over x plus 3. Nice and easy, soft, a capital T. Now let's move on to part 3. Part 3 says that, given that 5 to the 3x minus 2 is equal to 7 to the x plus 2, show that x is that expression. So pretty much they want us to solve for x, but don't give the exact value. So part C, you have 5 to the 3x minus 2, and it's equal to 7 to the x plus 2. Anytime the unknown is in the power, you take logs of both sides. Before you do anything, anytime unknown is in the power, take logs of both sides. So the first thing we're going to do is log both sides. So if 5 to the 3x minus 2 is equal to 7 to the x plus 2, then the log of 5 to the 3x minus 2 is going to be equal to the log of 7 to the x plus 2. Nice and easy. That's all. Now if these are equal, what can we do? Bring down the power now. So let's bring down the power. So that means 3x minus 2 times the log of 5. So 3x minus 2 times the log of 5 is equal to x plus 2 times the log of 7. X plus 2 times the log of 7. Nice and easy. What do we do now? We just need to expand out both the left hand and the right hand side. So let's expand out the left hand side. Expanding the left hand side, we're going to get 3x log 5 minus 2 log 5, and that is going to be equal to x times log 7, so that's now x log 7 plus 2 log 7. Now, only thing that's required now is to have the x's on one side. So what I'm going to do is bring over this x over here and bring over that over there. So bringing over the x over here, I'm going to have 3x log 5, 3x log 5, and then I bring over the x over here to get minus x log 7. That's of course going to be equal to, I bring over the 2 log 5 over to this side to get 2 log 5 plus 2 log 7. Nice and easy, nothing hard there. All right. Now see that we have x now. The only thing we need to do over to this side is factor out the x. So when we factor out the x, we're going to be left back with 3 log 5, 3 log 5 minus log of 7. 3 log 5 minus the log of 7, and that is equal to, we can factor out the 2 now, so we factor out 2, and what are we left with? When we factor out the 2, we're left with log 5 plus log 7. In order to make x the subject now, all we need to do is divide both sides by 3 log 5 minus log 7. So when we do the division, we divide both sides by 3 log 5 minus log 7. Nice and easy. And now we know what x is, because this cancels this. So the final answer is 2 log 5, 2 into log 5 plus log 7 divided by 3 log 5 minus log 7. Now 3 log 5, this is the same as 3 log 5 is the same as, I can write that as, I can write that as log 5 cubed. You can write that as log 5 cubed. And so finally, in conclusion, just to put the final answer over here, x is equal to 2 times log 5 plus log 7, 2 times log 5 plus log 7, and all of this is of course divided by log 5 cube, and log 5 cube is the log of 125 minus the log of 7. Nice and easy, soft, no issues. Now we're able to move on to question number 2. Let's go to question number 2. Question number 2 gives us a function. It says f of x is equal to 3x squared plus 6x minus 1. F of x is equal to 3x squared plus 6x minus 1. And then, of course, they're going to ask you to put it in its vertex form, meaning for you to complete the square. All right, we've all been doing this. We've been doing this for so many times now, from Csec math and now to add math. So we've been doing this long. So we can identify that the coefficient of x squared, we call it a is 3, our b is 6, and our c is -1. Nice and easy. Now we have all of these values now. And so now it says express f of x in the form a times x plus h squared plus k. So first we need to find is h, and h is equal to b divided by 2 times a. b divided by 2 times a. And so what is b? b is 6. And so it is 6 divided by 2 times 3, which is 6 divided by 6. And 6 divided by 6 is 1. All right, so that is h. So h is equal to 1. Next we can find k. Now k is equal to 4ac minus b squared over 4a. This is the formula for finding k. I know it's a little lengthy, but we've been used to it now. 4ac minus b squared over 4a. So now, all we need to do now is plug in now what is a. A is 3, and so k is equal to 4 times 3 times c, and c is minus 1, minus b, and b is 6 square, and then we divide it by 4a, which is 4 times 3, which is 12. That will give us k. So let's work out that. So what are we getting? 4 times 3 times negative 1 minus 6 square divided by 12, I get negative 4. And so now, putting f of x in the form that they want, we can finally tell them that, okay, f of x is equal to a. A is what? A is 3. So it's 3 times x plus h. What is h? 1. So it is x plus 1 square plus k. What is k? Negative 4. So this takes care of part 1. This is the solution for part 1. Nice and easy. Then it says state the minimum value of f of x. The minimum value of f of x is k. Always remember that minimum value of f of x is equal to k. And so minimum value of f is, what is k? K is negative 4. That's the minimum value of f of x. Then it says determine the value of x for which f of x is minimum. So the value of x for which f is minimum is x equal to minus h. So that is, i.e., x equal negative 1. That's the value of x for which f of x is minimum, negative 1. Nice and easy, soft. So that's part 2 and part 3 done and dusted. Part 2 and part 3 out of the way, nice and easy, soft, 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 soft. Nice. Now let's continue. Now part 3, or part B actually, part B says find the set of values for x for which 2x squared plus 3x minus 5 is greater than or equal to 0. So it tells us that we have 2x squared plus 3x, 2x squared plus 3x minus 5 is greater than or equal to 0. Find the set of values for x for which this inequality is greater than or equal to 0. Nice. So first thing we're required to do is factorize this expression. Let's go ahead and factorize it. All right, it's easy to factorize with the I. How do I factorize it with the I? Well, first thing you're going to ask yourself, 2x squared. That has to be 2x times x. All right? And then the next thing you ask yourself is 5. Which two numbers will times to get 5? That must be 5 and 1. That has to be 5 and 1. 5 and 1. And the next question is, how do I know which signs to go where? This means signs are different, but the bigger number is positive. So the plus goes here and the minus goes here. All right. And it's always good to get a sketch of what's going on. So this is a rough sketch of the quadratic, right? I know it's very poor, it's very tacky. This is the line y equals 0, but the part of the solution that we want is when y is greater than or equal to 0. And so if these are the roots, if this is the root, right here and right here, then the part of the solution we want is when y is above the x-axis. So these are the actual solutions that we want. Nice and easy. Those are the actual solutions. So if this would be x equal 1, this would be x equal minus 5 over 2. Nice and easy. All right. And so the solution that we want is x. Solution that we want is x is less than or equal to minus 5 over 2. X is less than or equal to minus 5 over 2. Or x is greater than or equal to 1. All right. Nice and easy. That's the solution. X is either less than or equal to 5 over 2 or x is greater than or equal to 1. Nice and easy. Now part 2. Part C, rather not part 2. Part C is a sequence question. And it says that find the sum to infinity of the finite series. All right. So part C, it says find the sum of the finite series. You notice that we have 1 over 4. And then the next thing you have is 2 over 4 squared. I like this question, 2 over 4 squared. And then next thing that you have is plus 1 over 4 cube. Then the next thing you have is 2 over 4 to the 4th power. And it goes on and on and on. But it's a finite series, all right? Now, you may be saying, whoa, how are we gonna do this? But it says the best way to do it, or the hint, is that you can write this as a sum of 2 series. So what does that mean? Write it as a sum of 2 series. We can identify, let's put it in red, the color red. We can rewrite this as 1 over 4 plus, now instead of saying plus 2 over 4 square, we can put the 1 over 4 cube. Plus 1 over 4 cube plus 1 over 4 to the 5th power plus, we'll continue. And we'll bracket that, because this is 1 series plus the sum of the second series now. And the second series would be 2 over 4 squared plus 2 over 4 to the 4th power plus 2 over 4 to the 6th power, and so on. All right, so we can break it up as this then. Nice and easy. Nice and easy. Nice, nice, nice. That's what we're doing. Now, right now what we can do is we have that. First thing we can do first is look at this. Remember, the sum of a, how do we find sum to infinity? That's a reminder. Sum to infinity, remember, is a over 1 minus r. That's sum to infinity. Sum to infinity is a over 1 minus r, where a is the first term. All right, a is the first term of the series, r is the common ratio. So what does that mean? That means that let's call all of this s. All right, let's call all of this s. All right, and so this is a formula for sum to infinity. And so what we're going to call it is s is equal to s1, which means sum to infinity of 1 plus sum to infinity of series 2. S is equal to s1 plus s2. Now, in order for us to know what s1 and s2 is, first and foremost, we need the first term is a quarter. All right, for this. So for this, it is s1, which is a quarter, divided by 1 minus r. And what's the common ratio for this? For this portion, the common ratio for this portion is 1 over 4 cubed divided by 1 over 4. So let's work out what r is. For this one, r is equal to second term divided by the first term, which is really 1 over 4 cubed multiplied by 4. Because dividing by a quarter is multiplying by 4. So that's 1 over 4 squared. That's r. R is 1 over 4 squared. Let's find the common ratio for this side. The common ratio for this side is the second term divided by the first term. So it's the second term is 2 to the 4th power. Dividing it by the first term is really multiplying it by the reciprocal. And the reciprocal is 4 squared over 2. That still just works out to be one common ratio. 2 cancel 2. It should be to the 4th power. 2 cancel 2, and 2 times 4 squared over 4 to the 4th times 2, that's just 1 over 4 squared. So the both of them have the same common ratio. So we get 1 over 1 minus 1 over 4 squared plus 2 over 4 squared over 1 minus 1 over 4 squared. That will give us the sum, the finite sum of this series. So this works out to be, just put this in your calculator. All right, now I'm just going to work out this portion first. So this is really 1 over 64. So 1 minus 4 squared is 16, sorry. So that's 1 minus 1 over 4 squared. That's 15 over 16. And a quarter divided by 15 over 16 is 4 over 15. So this part works out to be 4 over 15. Then we're adding it to plus. Again, down here is 15 over 16. So now we have 2 divided by 4 squared, and that's divided by 15 over 16. That's 2 over 15. So the finite sum is 6 over 15. You may be tempted to want to express it in terms of a lower fraction, but it doesn't matter. So if you want to write it as 3 into that 2 times, 3 into 15 5 times, 2 over 5, that's up to you. You may write it how you want to. This takes care of question 2. Now on to question number 3. Question number 3 is usually vectors. Vectors, equations of circles, and trigonometry. Let's look at question 3. Question 3. It says we have a circle C has center with coordinates 2, 1 and passes through the point 10, 7. And then it says find the equation of the circle and express it in that form. So they tell us that we have a circle, right? I just like to draw a sketch always. And it has center, and the center they tell us is 2, 1. And they tell us that the circle also passes through 10, 7. So 10, 7 would be somewhere up here. Right? So this is B. Now once they give you the center and a point on the circle, then clearly you know the radius. As this point B is 10, 7. So you know the radius. This is 10, 7. So you know the radius. What is the radius? The radius is going to be equal to the distance AB. That's the radius. Now, since that's the radius, then we can find the distance AB. The distance AB is equal to the square root of x1 minus x2. So 10 minus 2 square plus 7 minus 1 square. That's going to be the radius. So now when we use this formula to find the radius, that's going to tell us that the radius is 10 minus 2 square. That's 10 minus 2 is 8. 8 square is 64. Plus 36, square root of that, that's 10. So the radius is 10. So therefore, the equation of the circle is going to be x minus the center, the x value at the center, which is 2. This is the equation of the circle, x minus 2 square plus y minus 1 square, and that's equal to r square. R square is 100. Now, we're not finished. They told us to put it in a particular form. So that's what we're going to do. To put it in that form, we need to expand this square up here. So expanding the square, this is now x squared minus 4x. X squared minus 4x plus 4. Plus, this part now is really y squared minus 2y plus 1. And that's equal to 100. All right. Now we can go ahead and put it in the form that we need it to be in. It says, put it in that form, it's going to be x squared plus y squared. And it's going to be minus 4x minus 2y. Now this 4 plus this one is 5. Then bring over the 100, it becomes minus 5 minus 100 is minus 95. This is equal to 0. So now we can use these now to determine what is h. H is the coefficient of x, and so h is equal to negative 4. K is the is that K? G is the coefficient of y, and so G is negative 2. And K is the constant, and K is negative 95. Nice and easy, soft. That's the first part of the question, part I. Now let's look at what part II has to say, the second part. Part II says, the line L is a tangent to the circle at B. Find the equation of the tangent. So this is the line L. Oops, that doesn't look like a tangent line. Let's fix that. So the line L is a tangent to the circle. All right, so the line L is a tangent to the circle at B. Find the equation of the tangent. In order to find the equation of the tangent, first thing we need to do is find the gradient of the tangent. To find the gradient of the tangent, we first find the gradient of the normal. It is the gradient of AB. This is the normal, and the normal is perpendicular to the tangent. So the gradient AB is going to be equal to y2 minus y1, so 7 minus 1 over x2 minus x1, x2 which is 10 minus x1 which is 2. So 7 minus 1 which is 6 over 10 minus 2 which is 8, and 6 over 8 is 3/4. 3/4, that's the gradient of AB. So since the gradient of AB is 3/4, then that means the gradient of the tangent is equal to minus 4/3. So now we can go ahead and find the equation of the tangent. Let's go ahead and find the equation of the tangent. So the equation of tangent. Let's go ahead and find the equation of the tangent. The equation of the tangent is going to be y minus the y value at B, it is 7, so it's y minus 7, and that's equal to the gradient of the tangent, which is negative 4/3, multiplied by x minus 10. And this is the equation of the tangent. They didn't ask to put it in standard form, and so I'd leave it right there. That's the answer. They didn't ask to put it in standard form, so just leave it right there. That's the equation of the tangent. Nice. Now part B now of question 3, part B. This part now, they said that it said the position vectors of 2 points P and Q are relative to the origin, and they said that, so they're telling us that the vector P is equal to 10I minus 8J. So pretty much they're telling us that vector OP, if I were to put it in vector form to make it easier, vector OP is 10 minus 8. This is vector OP, 10 minus 8. And then I need vector OQ. Vector OQ is going to be what they give, it's lambda 10. Lambda 10. All right, that's what they gave us. And then what's the next part of the question? The next part of the question says, find the value of lambda such that the two vectors are perpendicular. So what they're telling us is OP, vector OP is perpendicular to vector OQ. Vector OP is perpendicular to vector OQ. Since vector OP is perpendicular to vector OQ, that implies that the dot product equals 0. Whenever two vectors are perpendicular, their dot product is equal to 0. So 10, 8, 10 minus 8, that lambda 10 is equal to 0. This will allow us to find the value of lambda. So now 10 times lambda is 10 lambda. So that means that we're getting 10 lambda, and then plus minus 8 times 10 is minus 80. So 10 lambda minus 80 is equal to 0. And so if we bring it over, we're getting, if we make lambda the subject, lambda is equal to 80 over 10. That's lambda. Lambda is 80 over 10. And if lambda is 80 over 10, then lambda equal 8. Lambda is equal to 8. Nice and easy. Soft. Well, let's look at the next part now. The next part, it says, part C. Part C says that the position vectors of A and B respect to a fixed origin O is given by OA is -2, 5, and OB is 3, -7. Find unit vector of AB. Now, first thing, before you can find unit vector, you need to find the vector AB. The vector AB is equal to vector of the last, which is OB, minus vector of the first, which is OA. So AB is OB minus OA. All right. So now that we're doing this now, so what we're getting is vector OB, which is 3, 3 minus 7. That's OB minus OA, and OA is -2, 5. That's equal to 3 minus -2, which is 5, and -7 minus 5 is -12. So that's vector AB. Now, how do we find the unit vector? The unit vector AB, this is unit vector. Unit vector is equal to 1 over the modulus of vector AB times vector AB. That's how we find the unit vector. This hat means unit vector. All right, so the unit vector AB is this. So all we need to do now is find the magnitude of vector AB. All right, so just to work it out right here, the magnitude of vector AB, is going to be equal to 5 squared plus -12 squared all square rooted. That's the magnitude of vector AB, which is 13. All right, so the magnitude of vector AB is 13. Now that we get that the magnitude of that is 13, then we can conclude that the unit vector AB is equal to 1 over 13 times, now all you need to do is put this back in the right form. 5i, put it in the ij form, so it is 1 over 13 times 5i minus 12j. All right, if you don't want to leave your answer like this, and you want to actually divide everything by 13, you could leave it as 5 over 13i, 5 over 13i minus 12 over 13j. It doesn't matter how you leave it, but this is the unit vector. Nice and easy, soft, the capital T. Nice. Question 4. Question 4 says, the diagram shows a sector cut from a circle of center O. The angle at O is pi by 6. If the perimeter of the sector is 5 over 6 times 12 plus pi, what is its area? So the diagram, it tells us that the angle is pi by 6. If the perimeter of the sector is 5 pi by 6 plus 12 pi, what is its area? So they're giving you the perimeter and they're asking you to find the area. That's a very good question. Why is it a good question? In my estimation, it's a good question because perimeter of a sector, as we know, the perimeter of a sector is 2r because you have the radius, you have, as we can see with the sector, these two distance is the radius. So this distance would be r, this distance would be r, and then this distance is the length of the sector. Or this is the arc length, all right? So it's 2r plus L. That gives you perimeter of a sector, all right? Perimeter is 2r plus L, but they give us that the perimeter, they told us that it is 5/6 times 12 plus pi. All right, that's what they told us. Now, there's no need to worry. We just need to find out what R is, because we can always find the area of the sector. All right, just to write down the formula over here, this is the formula that we're going to use to find the area of the sector. Area of the sector is equal to, as we learned from Csec mathematics, it's theta over 360. You can write it as theta over 2 pi times pi r squared. This is area of a sector, theta over 360 times pi r squared. That's area of a sector. So all we need to do is find out what r is. So 2r plus r times theta, but what is theta? It told us that theta is pi/6. So pi/6 times r is r pi/6. R pi/6. And that's equal to 5/6 times 12 plus pi. So look what I'm going to do. I'm going to write this as one fraction. Right, write this side as one fraction, and writing it as one fraction, multiply the 6 up here to get 2. So this works out to be, this is over 1. 1 into that 6 times, so this becomes 12r plus 6 into this goes 1 time, so I get r pi. And so from this, I can factor out r. Factoring out r, I'm going to have r over 6 times 12 plus pi. All right, now look at this. Voila, we get what r is, because remember what the question said. It said the perimeter is this, and we also work out that the perimeter is this. So if these two are equal, then clearly r is equal to 5. So the radius is equal to 5. Now that the radius is equal to 5, we can find this area of the sector. Area of the sector now is equal to theta over 2 pi. So this is pi/6 divided by 2 pi. Pi/6 divided by 2 pi multiplied by pi r squared. So it's multiplied by pi times r squared, and r squared is just 5 squared. Now pi/6 divided by 2 pi, as some would say, this is let me see, pi/6 divided by 2 pi. I'm getting 1 over 12. So I'm getting 1 over 12, and 5 squared is 25. So this works out to be 1 over 12. Works out to be 1 over 12. I'll make it even. That works out to be 1 over 12 multiplied by 25 pi. Some persons might want to write it a little bit better and say, well, that's just 25 over 12 pi. That's the area of the sector, 25 over 12 pi. 25 over 12 pi. And remember, area is always centimeter square in this case. Nice and easy, soft. Let's look at the next part of the question. The next part of the question is a trig equation. Them could be so nice, man. They give us a nice equation to solve. They set us to solve 2 cos square theta, 2 cos square theta plus 3 cos theta. 2 cos square theta plus 3 sine theta equals 0. This is what they're asking us to solve. Now, there are many ways to go about solving this equation, many different ways, but the easiest way, in my estimation, is to rewrite cos theta as 1 minus sine square. You can rewrite cos square theta as 1 minus sine square theta. That's the easiest approach in my estimation. All right, 1 minus sine square theta. Then you have plus 3 sine theta. Nice and easy. And that's equal to 0. All we have to do now is multiply through by 2 to get 2 minus 2 sine square theta. 2 minus 2 sine square theta plus 3 sine theta. And that's, of course, equal to 0. Nice. So this is what we're about to solve. We're about to solve this equation. But I don't like when this is negative, so I'm going to bring everything over to the other side and write 0 is equal to 2 sine square theta minus 3 sine theta minus 2 minus 3 sine theta minus 2. That's what I'm going to write. Now, if you call sine theta y, let y equal sine theta, just because you don't have to do it, but it makes it easier. If you call y sine theta, if y is equal to sine theta, you notice that you really have a quadratic. And so the quadratic that we really have is 0 is equal to 2y squared minus 3y minus 2. That's what we really have. We really have a quadratic. So since we have a quadratic, right, 0 is equal to this. So now we can go ahead and factorize it. And so what we have is 2y, y, it's 2 and 1. And it says, well, the 2 shouldn't be right there. I put this in the wrong place. Put this at the wrong place. It should be the 2 right here and the 1 right here. Signs are different. The greater number is negative. So minus goes here and plus goes here. So what does that mean? That means a lot of things. All right. So that means that from right here, it is telling us then that y is equal to negative a half. Y is equal to negative a half, or y is equal to 2. That's what they're telling us. Y is equal to negative a half, or y is equal to 2. Now let's split it and work out the next portion here. Now, if y is equal to negative a half, that is not possible. How can y be negative a half? All right, so if y is equal to negative a half, that's just not possible. Y equal negative a half, not possible. Well, this one is possible, my apologies. Y is negative a half, and we said y is sine theta, then sine theta is negative a half. My apologies for saying this one is not possible. This is possible. Sine theta is negative a half. The other one on the other hand, which was saying y is 2, sine theta cannot be 2. This one is not possible. This one, sine theta cannot be equal to 2. Sine theta equal to, this one is not possible. So you can tell them that this one is madness. Don't be afraid to express yourself. Tell them that is madness. And I tell them that's madness. This don't make no sense. That's madness. All right, so now sine theta is minus a half. So we want when sine is negative in this quadrant. So you have to remember this. All schools teach crap. All schools teach crap. And so sine is positive here and here, but we want when it's negative. So first we're going to find what's known as the principal acute angle, which is sine inverse of a half. And so the principal acute angle, I can call it x, is going to be sine inverse of a half. Sine inverse of a half is 30 degrees. So that's the principal acute angle. But the angles that we want are in this quadrant and this quadrant. In this quadrant, the angle is going to be pi plus the principal acute value. And in this quadrant, it is 2 pi minus x. And so now we can talk what is theta. Theta is going to be equal to pi, which is 180 plus 30. So theta is equal to 210 degrees, or 360 minus 30, which is 330 degrees. Those are the possible values for theta. And if you don't believe your answer, you can check it. Put in a calculator 2 times cosine 210 square plus 3 times the sine of 210. You get your 0. So you say that this is right. Nice and easy. And that takes care of part 2. Now let's look at part C now. Nice and easy. Part C. Part C says now we are to, given that the tan of theta minus alpha is a half and tan theta is 3, use the appropriate compound angle to find the value of the acute angle theta. Alpha. Why am I saying theta? So it tells us that the tan of theta, tan theta minus alpha. Now tan theta minus alpha, they told us that is a half. Now no need to worry at all. Now this is the tan of A minus B. Tan of A minus B is equal to, so this implies tan of theta minus alpha is equal to tan theta minus tan alpha over tan theta minus tan alpha over 1 minus tan theta times tan alpha. All right, this is the formula for expanding the tan of theta minus alpha. And this is equal to a half. Now remember, what is tan theta? They said tan theta is 3. So replace this with 3. So that's really 3 minus tan alpha over 1 minus 3 tan alpha. And that's equal to a half. So cross multiply it now. And so what are we getting? We're getting 3 minus tan alpha. That's equal to a half times 1 is a half. Minus a half times 3 is 1.5 tan alpha. Nice and easy, soft. So now we bring over tan alpha. We can bring over the 1.5 tan alpha over here. Bring over the 1.5 tan alpha over here. 1.5 tan alpha go over here. then minus tan alpha. So we're going to get a half tan alpha, a half tan alpha, a half tan alpha is equal to 1.5. So this is what we did. This 1.5 and this minus tan alpha, bring it to one side. Then let's bring over the 3 over to this side now. So 0.5 minus 3 is minus 2.5. So what are we saying? We're saying then that tan of alpha is actually equal to, we divide by a half both sides, so minus 2.5 divided by a half, that's negative 5. So tan alpha is actually negative 5. That is the value for tan of alpha. Again, you draw your circle. Let's draw a better circle. That's the circle. All right, so our principal value, let's call it x. X is equal to tan inverse of 5. That's the principal angle, tan inverse of 5. All right, x is tan inverse of 5. What is tan inverse of 5? Let us see. Tan inverse of 5 is 78.7 degrees. 78.7 degrees. Now it's C-A-S-T. All right, C-A-S-T. Now, this is what we have, C-A-S-T. C-A-S-T. All right, and we need when tan is negative. Tan is negative here and here. That's where tan is negative. All right, so this would be pi minus, but this won't give the acute angle. All right, and then here would be pi plus, but this won't be acute either. And so we work with this. So the angle is 78.7 degrees because they said acute angle. All right, so in this case, alpha is 78.7. And if you want to check back your answer, you can always check it to see if tan alpha is what? Tan alpha is 3, so you can check it out. 3 minus tan theta is 3 minus tan alpha. Tan alpha is negative 5, so 3 minus negative 5 divided by 1 minus tan theta tan alpha, which is 3 times negative 5. So it's 1 minus 3 times negative 5. And you get your half. So yes, well, nice. This is right. Alpha is 78.7 degrees. Nice and easy. And that takes care of question 4. Now we can go to question 5. The easiest part of the paper, differentiation. Question 5. Question 5 says, y is equal to x cubed minus 3x squared plus 2. Y is equal to x cubed minus 3x squared, x cubed minus 3x squared plus 2. That is y. 3x squared, x cubed minus 3x squared plus 2. Find the stationary points of y. Stationary points occur when dy by dx is equal to 0. That's where stationary points occur. So find dy by dx first. And dy by dx is going to be 3x squared minus 6x. Right, that's dy by dx. And they said for the stationary point, you know that dy by dx is 0. So solving 3x squared minus 6x equals 0, we're going to get, if we divide through by 3, we're actually solving x squared minus 2x equals 0. And so the stationary values of x are going to be x equals 0 or x equals 2. But they said points, they want the stationary points. So we need to plug in 0 up here to get the corresponding y value. When x is 0, y is 2, comma. When x is 2, we're going to get 2 cubed minus 3 times 2 squared plus 2, which is negative 2. So y is going to be negative 2. All right. So now we get our two stationary points. So let's write it down right here. So the stationary points are 0, 2, and 2, negative 2. Those are the stationary points. Now it says, find the second derivative of y and hence determine their nature. Now, second derivative is used to determine the nature of each stationary point. So let's go ahead and do that. So the second derivative is d2y by dx squared. That is second derivative. d2y by dx squared. So we'll find d2y by dx squared. d2y by dx squared is going to be, we're going to differentiate this dy by dx. So d2y by dx squared is going to be 6x minus 6. That's d2y by dx squared. Now, we're going to plug in the 2 points now to determine which one is minimum and which one is maximum. So at 0, 2, what we're going to notice is that d2y by dx squared is going to be, when we plug in 0, when we plug in x at 0, we're going to get 6 times 0 minus 6. So we're going to get minus 6. Now minus 6 is negative, which is less than 0. And so this is a maximum point. So 0, 2 is a maximum point. This is maximum point. All right, so I'm just going to write max for now. Then we need to find out at 2, negative 2. At 2, negative 2, let's see what is happening. At 2, negative 2, we're going to get d2y by dx squared. And that's going to be equal to 6 times 2, which is 12. 12 minus 6 is positive 6, which is greater than 0. And that's a minimum point. Min. All right. So what can we conclude? We can conclude that 0, 2 is a 0, 2 is a maximum stationary point. And 2, negative 2 is a minimum stationary point. Nice and easy. That's what we can conclude. Now we have one more part of this question to do. It says differentiate y equal 5x plus 3 all cubed sine x, and it says to simplify your answer. So of course we're going to use product rule to do this. So y is equal to 5x plus 3. Y is equal to 5x plus 3 cube multiplied by sine x. And we're required now to differentiate this as far as we can go. So dy by dx is going to be equal to, dy by dx is equal to, keep the first. So we'll keep the first, we'll get 5x plus 3 all cube times the differential of the second. When we differentiate sine x, we get cos x plus, keep the second, which is sine x, times the derivative of the first. Now when we differentiate the first one, we're going to bring down the power 3. We're going to subtract 1 from the power. It's 3 times 5x plus 3 all square. And then we multiply it by the derivative inside the bracket, which is 5. Nice and easy. So this works out to be 5x plus 3 all cubed. 5x plus 3 all cubed multiplied by the cos of x. Plus, let's simplify over this side now. 3 times 5 is 15. And so we'll get 15 times 5x plus 3 all square times the sine of x. That's dy by dx. Nice and easy. Now it says simplify it as far as we can go. So if we want to go further, I realize that 5x plus 3 all square is in common with both of these terms. And so I can factor out a 5x plus 3 all square. If I factor out a 5x plus 3 all square, what I get left back with is, right here, so it becomes 5x plus 3 times cos x. 5x plus 3 cos x. And it's then going to be multiplied, 5x plus 3 multiplied by cos x plus, I'm just left back with plus 15 sin x here. So this is as far as I can go in terms of simplifying it. All right, that's for me. This is as far as I can go. That's it. That's dy by dx. Nice and easy. Soft. All right. Now we go on to integration now. Integration. Question 6. It says, find the integral of 5x squared plus 4. That's a very easy question or non-challenging question. They want us to integrate 5x squared plus 4. So as we know, the general rule of integration is we add 1 to the power and then we divide by the power. So we have 5x squared plus 4 dx. We're just going to add 1 to the power, adding 1 to the power x squared, so we get 5x cubed. Then we divide by the power, the new power 3 plus, add 1 to the power, so it becomes 4 times x to the 1 divided by 1. But anytime you integrate like that, you put plus a constant of integration c. That takes care of part A. Nice. Now the next part of the question says, evaluate the integral from 0 to pi by 2 of 3 sine x minus 5 cos x. Let's go ahead and do that. Compute the integral from 0 to pi by 2, 0 to pi by 2 of 3 sine x 3 sine x minus 5 cos x dx. So now to do this integration is fairly simple. All right, so to carry out this integral now is now 3 sine x. Now when you integrate sine, you get minus cos. So this is going to work out to be minus 3 sine x minus 3 sine x. Then when you integrate cos, you just get sine. So it just becomes minus. When you integrate sine, you get minus cos. It should be minus cos right here. Minus 3 cos x. And then when you integrate cos, you get sine. This becomes minus 5 sine x. And we're integrating, of course, from 0 to pi by 2. We're integrating from 0 to pi by 2. All right, so since we're integrating from 0 to pi by 2, this is going to work out to be, we're going to substitute x as pi by 2 first. So it's going to be minus, when you plug in pi by 2 for x, it's going to be minus 3 cos pi by 2. Well, yeah, let's write them out. So minus 3 cos pi by 2 minus 5 sine pi by 2 minus when we put in 0. Minus when we put in 0. When we put in 0, well, the cos of 0 is 1, so that works out to be minus 3 minus 0. So let's work this out. Now the cos of pi by 2, the cos of pi by 2 is the cos of pi by 2. This is 0, so it works out to be, sine of pi by 2 is 1, so it works out to be minus 5 minus minus 3. Minus 5 minus minus 3 is minus 5 plus 3, and minus 5 plus 3 is negative 2. So that's the integral of that, negative 2. Nice and easy, soft. Now let's look at the next part of the question. It says a curve passes through the points 0, 8, and 4, 0. And it says find the area of the finite region bounded by the curve in the first quadrant. So guys, I always like to have a little sketch of what I'm doing. All right, they tell me have a point 0, 8. So this would be the point P. And you have the point Q, which is 0, 4. This is the point Q. So this is the region. Let's just say it's a curve. All right, this is from P to Q. And they want the area of the finite region, mean they want inside here. This is what they want. All right, so first thing is we need to find this curve, whatever this curve is. All right, so remember P is the point 0, 8, and Q is the point 4, 0. So we need to find out the equation of this curve first. In order to find the equation of the curve, we need to integrate dy by dx. So what we're going to say then is the equation of the curve is y is equal to the integral of 2 minus 2x the integral of 2 minus 2x, that's y, minus the integral of 2 minus 2x. We'll do this integration. What we're going to get is, this becomes 2x minus, integrate 2x, that becomes x squared over 2 plus some constant c. So this is y. Y is equal to 2x minus x squared over 2 plus some constant c. But we need to find this constant c. How are we going to find this constant c? Well, we can use we can use this point 0, 8. When y equal 8, so when y is equal to 8, x is 0. And so what are we getting? We're getting that 0 minus 0, 0 minus 0 plus c. So this gives us the equation of the curve. And so finally we can conclude that y is equal to, I'm going to write it as minus x squared over 2 plus 2x plus 8. That is y. Y is minus x squared over 2 plus 2x plus 8. All right. And then it says find the area of the finite region bounded by the curve in the first quadrant. So to find the area is going to be equal to the integral of the curve from x being 0 to x being 4. So we're integrating from x being 0 to x being 4. And what are we integrating? We're integrating minus x squared over 2 plus 2x plus 8. Dx. That's equal to, now we integrate now, it becomes minus x cubed over, now add 1 to the power, divide by the power, we're dividing by 3, and 3 times 2 is 6, plus, add 1 to the power becomes 2x squared over 2, and add 1 to the power becomes plus 8x. And so now we're integrating, of course, from 0 to 4. So let's work this out now. All we need to do is plug in 4, because we don't need to plug in 0, because 0 times any of these numbers is 0. So we'll plug in 4, minus 4 cubed, that's minus 64 over 6. And then we have plus x squared, which is 4 squared, which is 16, plus 8 times 4, which is 32. So let's see what this area works out to be. That's 16 plus 32 minus 64 over 6. And I'm getting 112 over 3. 112 over 3 units squared. That's the area. Nice and easy. And that's question 6. Soft. All right, now let's look at question 7. Question 7 says, let's go to question 7. Question 7 says, of the persons buying petrol, it says that 40% are females, and of the females, 30% pay for their petrol with cash, and of the males, 65 pay for their petrol with cash. Copy and complete the following tree diagram. So as you can see, from this tree diagram that we're seeing here, you have 2 people paying for petrol. You have females and you have males. All right, females and males. All right, and females, they're paying with, let me use a different color here. Females and males, they're either going to pay with cash or they're going to pay with something else. That's probably credit card. More than likely it's credit card or debit card, something along that sorts. All right, so this is females and this is males, and 40% are females, so that's 0.4. So 60% are males, that's 0.6. All right, next thing now is that how much pay with cash? Let's call this cash. All right, let's call this cash. Now, he told us that of the females, 30% pay with their cash. So 0.3 pay with cash. So that means a 70% pay with other. All right, 0.7 pay with other. All right, and then for males now, it says 65% pay with cash. And so that means 35% pay with other. %65 pay with cash. Nice and easy. Now it says, what is the probability that a customer pay for petrol with cash? Now the probability the customer is going to pay, so probability the customer going to pay with cash, let's work that out. I'm going to call cash C. Let's just call it C. The probability the person is going to pay with cash, I'm calling it C. The probability of the person paying it with cash, it can either be a female and paying with cash, so it can be 0.4. Probability of female times cash, 0.3, plus it can be a male that is also paying with cash, so that's 0.6 times 0.65. That will give you the probability of a person paying with cash. So 0.4 times 0.3 plus 0.6 times 0.65, that's 0.51. All right, so that is, there is a 51% chance, there's a 51% chance a person pays with cash. All right, so 51% chance a person will pay with cash. Now, what is the next part of the question? The next part says, determine which is more likely event. Which is more likely means which of these have a greater probability of occurring. All right, which of them have a greater probability of occurring? Now let's look. It says, customer is a female given that petrol is paid with cash. So let's check out event T. What's the probability of event T happening? All right, let's work that out. The probability of event T occurring. All right, but what is really event T? Event T is the probability of customer is female given that petrol is paid with cash. So the probability being female given that petrol is being paid with cash. All right. So now the probability of being a female and paying with cash, that's going to be equal to the probability of F intersect C, that's the probability of being a female and paying with cash divided by the probability of paying with cash. All right, so the probability of being a female and paying with cash is 0.4 times 0.3. That's the probability of being a female and paying with cash. And that's now divided by the probability of a person in general paying with cash, which is 0.51. So now what is that? 0.4 times 0.3 divided by 0.51. That's 0.235. This is 0.235. That's the probability of event T occurring. That's the probability of event T occurring. So now let's say the probability of event V occurring, which is a male customer who does not pay for petrol with cash. So the probability of V, which is a male customer who does not pay with cash. So the probability of being a male customer, so this is a male customer and what? And don't pay with cash. Probability of being a male customer and don't pay with cash. So we said cash is C, so the probability of M intersects C. So the probability of being a male customer and don't pay with cash is 0.6 times 0.35. All right. What is 0.6 times 0.35? So 0.6 times 0.35 is 0.21. So there's a greater chance of a customer being female given that they pay with cash. All right, so there's a greater chance of event T occurring. So let's write the conclusion. Always finish with your conclusion. Don't just work out and don't tell them what are you concluding. Give them the conclusion. So event T is more likely to occur. So that is, there is a greater chance of a female, there's a greater chance customer is a female given that the petrol is paid with cash. Nice and easy, soft. Now we move on to part B of this question. Part B gives us some marks, right? And it says, state one advantage of using stem and leaf versus a box and whisker to plot the display of the data. So we want to state one advantage of stem and leaf over the box plot. So the stem and leaf, it displays all, how can I say, it displays all data points, where the box plot, the box and whisker or box plot only displays the summary statistics. So the box plot, it only displays the median, the upper quartile, the lower quartile, all right, and it also displays the upper hinge and lower hinge. Those are all the box plot display. And we can say as a result, we are unable to find mode and mean from a box plot, but we can compute mean and mode from a stem and leaf diagram. So this is one advantage of the stem and leaf above. This is one advantage of the stem and leaf. So now the next part of the question says, construct a stem and leaf diagram to show the data. So I want to construct a stem and leaf to show the data. All right, so I'm just going to write out all the data. It makes it easier right here. So just rewriting all the data. As we see, it's 58, 92, 41, 89, 72, 66, 51, 63, 63, 80, 40, 69, 45, 83, 76, 53, 56, 75, 50, 99, 50, 85, 63, 58, 75, 66, 56, 81, 74, 51, and 94. Now, one thing before we even continue, I just want to say this student that got 99 on an English exam is fantastic. I don't know what kind of student gets 99 on an English exam, but that student is exceptional. So let's construct our stem and leaf diagram. So this is the stem. All right. Then over here be the stem. And over here be the leaf. All right. And so, of course, we'll put our key later down. Okay. So, of course, we have to start from, we need to, is there anyone in the 30s? Anyone in the 30s? Just to be safe, I usually write 3, 4, 5, 6, 7, 7, 8, 9. Just to be safe. Is there anyone in the 30s? It's good to do that. Anyone in the 30s? No 30s here. No 30s. Anybody in the 40s? I say 40, so we can put a 0. So underline this 40. This is out of the way. I say a 41, so we can put a 1 here. Get this one out the way. Let me change the color so I'm not confused. I want it in order. Is any other 40? Let me see. No more 40s. No more. There's a 45 here. So this is the 45. We can put the 5. Let's go in the 50s now. Anybody with 50, of course. Somebody after Bailey Parks, that's 50. When we look again, there's another 50. Somebody, this person scraping the pass mark, the Bailey scraping. All right, scraping, scraping. This is 51, scraping. Like it's bottom of the porridge, 51. All right, and we're gonna look for 52. Is there any 52? I don't see any 50. This is another 51, another scraper. Right, 52, any 52? Can't see any 52. So I'm gonna assume that the next one is 53. Here's 53. No more 53. 54. No, 54, 55, 55 should be here. 55, 55, 55. Don't see any 55. 56. Here's a 56. You can put 6 right here. See another 56. Here's another 56. And put another 6 here. Then it asks for, let me see now, 57. No 57, but I see 58. And put my 8 here. And I see another 58. And I can put another 8 here. All right. And then now what else now? 59. 59. No 59. No 59. That's crazy. Let's go for 60 now. Where is 60? 60 is there any 60? No 60. So no 60. I say a 63, however. I see a 66. And I see a 69. You know, going into the 70s. Going into the 70s, going into the 70s. Now we see a 72. And this is a 74. And let's see a 75. And let's see a 75 here. And what else now? Here's a 76. Need a 77 now. How do I find 77? No 77? No 77. And here I missed out. Oh, I missed out a 63 here. So it's a good thing I was looking back. So I missed out some 63s. Another 63 was supposed to be here. Here it is. And a 66. So it's 266. And then the 69. Good. Now we're into the big boy territories, the 80s. So we have a 81. Let's speed it up now. We get the process. We have a 80. So we have 80. We have a 81. Here's the 80. Here's the 81. We have a 83. Then we have a 85. Then we have a 89. Then we're going into the 90s now. In the 90s, we have 92. We have 94. And of course, we have this magical English student that got 99. I don't know how. That's that. This should be 30 grades. Just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 20, 29, 30. So we're good. 30. So that's the stem and leaf. It says determine the median mark. So the median is Q2. So the median mark Q2, the median occurs midway at it's going to be the 15.5 position. That's the median, 15.5 position. All right, so 15.5 position is going to be in between. Let's go there. 15.5, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the median is in between here. So the median Q2 is equal to 66. That's the median. That is, the median is 66. Then it says now, calculate the semi-interquartile range. First and foremost, the semi-interquartile range is going to be equal to the interquartile range divided by 2. That's semi-interquartile range. Interquartile range divided by 2. That's semi-interquartile range. All right. And so to find the interquartile range, it's going to be Q3 minus Q1 over 2. Q3 minus Q1 over 2. All right, so let's find Q3. Now, the position of Q3 is going to be 3/4 of n plus 1. So it's going to be 3/4 of 31. And that's the 23rd and a quarter term. So let's go there. All right, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be the 8th term from here. 1, 2, 3, 4, 5, 6, 7, 8. So this is Q3. Q3 is 80 minus Q1. Q1 is the 8th term from here, which is 1, 2, 3, 4, 5, 6. So we're going from here. All right. So we're going from here. So with here now, we're going here. 1, 2, 3, 4, 5, 6, 7, 8. So this is what I'm getting for Q1. Q1 is 53. So the semi-interquartile range is 80 minus 53 over 2. So what is the semi-interquartile range? The semi-interquartile range is 80 minus 53 divided by 2, which is 13.5. That's the semi-interquartile range. If you want to know how I found out these, think of it this way. After you reach the middle number 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Think of it as splitting the data in half right here. All right, you split the data in half. When you split the data in half, you have 15 terms here and 15 terms here. So to get the Q3, just find the median of these 15 terms. So you go 1, 2, 3, 4, 5, 6, 7, 8. So that's how you get Q3 to be 80. To get Q1, you have 15 terms here. So find the middle term of these 15, which would be 1, 2, 3, 4, 5, 6, 7, 8. That's how you get the semi-interquartile range. Finally, it says 2 students are chosen at random. It says determine the probability that both scored less than 50 on the exam. So the probability that both of them scored less than 50. So the probability that the students grade, both of them, score is less than 50 is going to be equal to, so this is V now. Probability that the student score is less than 50 is going to be 1, 2, 3. There are 3 students that scored Less than 50. Probability that the score is less than 50 is 3 out of 50. All right. That's the probability of a student's score being less than 50. Well, that's a probability of one student getting less than 50, and it said 2 students. So let me call this S2. The probability of both students getting less than 50 is the first boy getting less than 50. Then when you take out that boy, you have 2 over 49. All right, so this is the probability that both of them get less than 50. So in reality, it's 6 over whatever is 50 times 49, 2,450. So that's a probability that both of them get less than 50. So it's pretty much saying it's very unlikely that 2 of them get less than 50 that are chosen. All right, let's go now to question 8. Question 8, it gives us a particle starts from rest. It says a particle start from rest, a particle starting from rest, and then it accelerates. Particle starts from rest and then it accelerates uniformly to 20 meters per second in 5 seconds. It continues for 10 seconds. It then accelerates again uniformly to 60 in 5 seconds. The particle then decelerates to come to rest. Draw the velocity time graph. So let's go to the graph paper and do this question. So we're on the graph. Let's construct this graph nice and easy. This is the graph that they will give you. Okay. They told us that the particle started from rest and then accelerates to 20 meters per second. So it starts and then goes to 20 meters per second in 5 seconds. So it goes right here. Then they said it continues at this velocity for 10 seconds. So 10 seconds more, 5 plus 10 is 15. It then says, it then accelerates again uniformly to a velocity of 60. So it accelerates up to 60 in 5 seconds. So that's 20. And then it says what? It then decelerates uniformly to come to rest 15 seconds later. 15 seconds later is 35. Nice and easy. Okay. That's it. So first 5 seconds go up to 20, next 10 seconds rest, next 5 seconds go way up to 60, then 15 seconds it come down. It says now, find the total distance in meters traveled by the particle. Total distance traveled is equal to area under the graph. Total distance traveled is equal to area under the graph. So this is how we're going to break it up. We're going to break it up as, call this A. Let's call this B. Let's call this triangle C. And then let's call this D. So the total distance traveled is the area under the graph. So total distance is equal to A. Area of a triangle is half base times height. So it's going to be equal to a half the base of 5 times the height of 20. So it's a half the base of 10. Not 10, why do I write 10? Half the base of 5 times a height of 20, that give you A, plus area of this rectangle is length of 10 times the length of 10 seconds times the width of 200. So 10 times 20, which is 200, that would be area for B, plus C is a triangle with a base of from 10 seconds, from 15 seconds to 30 is 15. So the base is 15 and the height is 40. This is plus a half the base of 15 times the height of 40. All right, then finally D plus D, and D is known as a trapezium. Area for trapezium is a half the sum of the parallel sides. So it's a half this distance, which is 15, plus this distance down here, which is 20 times the perpendicular height, and the height is 20. All of this, when you put it in a calculator, will give you the total distance traveled. So the total distance is a half of 5 times 20 plus 200 plus a half of 15 times 40 plus a half of 15 plus 20 times 20. So this is 900. So the total distance traveled is 900 meters. So let's go ahead and do that now. We can write that down. The total distance traveled is 900 meters. So from the graph, we determined that. So part A, total distance traveled is 900 meters. That's the total distance traveled. Next, it says find the average velocity of the particle. Now this is simple now, average velocity. To find average velocity V is equal to total distance divided by total time. That's average velocity, total distance over total time. Now the total distance is 900 meters. Total distance over the total time, that's average velocity. Total distance over total time. Now the total distance is 900 meters divided by the total time. And the total time is what? The total time is, I think, 35 seconds to come back down to race. So 900 divided by the total time of 35, and that will give us the average velocity. And the average velocity is therefore 25.7 meters per second. Nice and easy, soft. Now part B, so this is now the real part B. Part B tells us that a particle travels in a straight line in such a way that after t seconds, its velocity v is given by, it tells us that the velocity of a particle is 3t squared minus 18, 3t squared minus 18, 3t squared minus 18t plus 15. That's the velocity of the particle. Now, if this is the velocity of the particle, what can we do? It says calculate the values of t when the particle is instantaneously at rest. The particle is instantaneously at rest when the velocity is 0. So when v is equal to 0, that's when the particle is instantaneously at rest. All right? Because think about it, instant rest means when you now move, like the velocity is 0. So all we need to do is at instantaneous rest, we set this equals 0. All right, so for part I, we set this equals 0. Now solving this equals 0, we can divide through by 3 to get t squared minus 6t plus 5, 6t plus 5, and that's equal to 0. Now we can then factorize this part equals 0. And so what is this? This is t, this is t, this is 5, this is 1. This is saying signs are same, both of them negative. Minus, minus. So what this tells me then is t is equal to 1 or t is equal to 5. That's when the velocity is instantaneously at rest. Now it says the distance traveled by the particle between 1 and 3 seconds. So part 2. Part 2, the distance traveled between 1 and 3 seconds. So that is the distance traveled between 1 and 3 seconds. Let's call that distance s. S is going to be equal to the integral from 1 to 3. S is the integral from 1 to 3 of the velocity, which is 3t squared minus 18t plus 15. So when we integrate this, and remember we're integrating with respect to t. Integrating with respect to t. So when we integrate this, what are we going to get? We'll call the distance s. So integrating, we get, add 1 to the power, so we get t cubed, because it's really 3t cubed, but when you divide it by 3, the 3 is going to cancel, minus 18t squared over 2, minus 18t squared over 2, plus 15t. And of course, we're going from 1 to 3. So when you plug in s as 3, what you're going to get is, plugging in 3 cube is 27, so we get 27, minus, plugging in 3 squared, you get 9. Oh, my apologies, and I forgot to multiply. Let's say 18 over 2 is 9, and then 3 squared is also 9, so it's 27 minus 9 times 9, plus 15 times 3. All right, and then of course we're subtracting when we plug in 1. 1 cube is 1, minus, plug in t as 1, 18 over 2 is 9, so minus 9. Then 1 times 15 is 15, so you get plus 15. So this works out to be equal to 27 minus 9 times 9 plus 15 times 3. That's negative 9. Minus 1 minus 9 plus 15 is 7. So minus 9 minus 1 minus 9 plus 15, as I said, 1 minus 9 is negative 8. Negative 8 plus 15 is 7. And so minus 9 minus 7 is negative 16. Now, don't worry, distance, the negative 16 doesn't mean anything. So this is the conclusion. So the distance traveled is 16 meters in the opposite direction. That's all the negative mean. You're traveling in the opposite direction from where you originally started. That's all that means. Let's change the color to maybe red. So that's the distance traveled. Nice and easy. Now part 3 of the question. Part 3 says, find dv by dt when t equal to. So dv by dt is going to be when we differentiate v. So dv by dt is, when we differentiate v, it's going to be carry down the power. So we'll get 6t dv by dt minus 18. That's dv by dt. So C part 1, they want dv by dt when t is 2. So when t is equal to 2, what we're getting is dv by dt is equal to, we're going to plug in 2. Plugging in 2, what we get is 6 times 2 is 12, and 12 minus 18 is negative 6. That's what we get, negative 6. And then now for part 2, we're plugging in t equal 3. T equal 3. When t is equal to 3, we plug in 3 and we get 6 times 3. 6 times 3 and 6 times 3 is equal to 18. 18 minus 18 is 0. So when t is equal to 3, we're getting dv dt is equal to 0. All right. All right. Nice. Now it says give an interpretation of this now. So give an interpretation. All right. So given the interpretation now, let's give the interpretation. So the interpretation is at t equal to the acceleration, dv dt is acceleration, so the acceleration is negative 6. So that means that the particle is decelerating. So that is, the particle is decelerating. All right, let's give an interpretation for part B now. So now at t equal 3, the acceleration is 0. The acceleration is 0. All right, that's what we know about t equal 3. And this wraps up the paper. Nice and easy. This was so easy. Soft, the capital T.